Known to all of you. Now, I would like to express my gratitude to the organizing committee to inviting me in the sixth PIMS conference as a speaker. In the history of pipelines, the learning. Now I am going to talk about the design, engineering, and construction of onshore pipelines because integrity starts from design itself. So in my opinion, this type of conferences in an endeavor towards exchange of information, experiences, and cross-fertilization of ideas to find the way forward to the pipeline industry. These are the topics which I am going to cover in this presentation. This is the pipeline infrastructure in India. If you see the maps, one is gas pipeline map and another one is liquid pipeline map. As our earlier speakers told that the total pipeline length in India is 57,000 kilometers, in which I can say that there are only two major players in India. One is IOCL and another is GAIL. GAIL is owning almost 20,000 kilometer pipelines and IOCL is owning 21,000 kilometer of pipeline. Means 70% is pipeline is covered by the two operators. And balance pipeline is by HPCL, BPCL, GSPL and many other companies. And this is the introduction of the pipeline. If you see the pipeline, basically to convey the fluid from one location to another location. There is a pipeline. This pipeline system is very economical, cost-effective, and efficient way to transport the system. As you know, our country is the most populous country. And we are having the world's #1 population. And our energy requirement worldwide, we are the third largest energy consumer in the world. As per our energy basket for gas-based economy, only 6%. But our government of India has basically given a target to the companies that our economy should go to 15%. Globally, it is 22%, and world is moving to 25%. But to lay the pipeline, to increase the gas-based economy from 6 to 15%, more number of pipelines are required. If you see, the pipelines have become significant propellers for the growth of the Indian industry. That's why to meet the energy demand of the most populous nation, too many and much more pipelines are required. Pipeline transport, crude oil, product, and gas, and many more. If you see the pipeline having compressors, valve station, control systems, and if you see, this is the pipeline provide the energy security to all consumers, whether it is residential, commercial, or industrial. Because pipeline transport the energy in continuous with minimal delays. Means it, like in tankers, it is basically in energy bundles, but in pipeline it is transporting continuously. So I can say that pipeline also enables the trade and commerce that generates, basically create jobs in construction, maintenance, operation of the pipeline. Therefore, pipeline remains an indispensable part of the energy sector, balancing efficiency and sustainability while providing evolving energy needs and environmental challenges. If you see, this is the way of transportation, as I told, means less energy requirement. For transporting the product or gas or any other fluid through pipelines, that energy requirement is approximately 0.5 to 2% as compared to 3.2% in road. If you're transporting the fluid through road, then its requirement is 3.2%. And negligible loss of product in transit. If you see 0.15% by volume transported through pipelines versus 0.35 to 0.5% in railroad. If you compare the transportation system by pipelines in India and America, India is still pipeline transporter is only 32%. 68% is transported by road, rail, and water carriers. However, in America, pipeline is 68%. Water carriers is 27%, and others is 2 and 3%. In America, pipelines are 5,73,000 kilometers. In China, 1,50,000 kilometers. In Canada, 1,17,000 kilometers. But in India, only 56 to 57,000 kilometers, though we are a most populous nation. This is the typical pipeline facilities, mean transmission line as well as spur lines. If you see the system, these are the dispatch terminal, SV station, intermediate pigging station, pumping station, receive terminal. If gas pipeline, then there is a compressor station. These are the basically project phases of the pipeline. One is design aspect, another is installation, and third one is operation. If you see design, basically there are many studies we have to carry out during designing. We follow different types of codes like API codes, ASME B31.8 for gas pipeline, 31.4 for liquid pipelines, and various analysis we have to carry it out, like API RP 1102 for rail and road, and for weldings API 1104, for walls API 6D, many more codes are there to design the pipelines. And there is a location class survey in case of gas pipelines. And whatever Bose Babu talked, that is HCA, high consequence area. Now it has been changed to CCA, critical consequence area in OISD 141, latest edition. And definition has been changed from HCA to CCA. Earlier it was 46 or more dwelling called HCA. Now it is different definition. That is totally defined in the OSD 141. Then there is a sectionizing wall. Nowadays there is a very much challenge about sectionizing wall installation because nobody able to procure the land to install the pipeline, SV station. That's why optimization of SV, we will define later in slides how location is selected for SV stations and how SV stations can be optimized. And materials like line pipe. If you see the line pipe, in pipeline almost 35 to 40% cost belong to line pipe. So line pipe is the very critical item for any pipeline system, for the integrity of the pipeline system. And last one is the cathodic protection, because if you see the pipeline is, I am saying pipeline is coated, but coating reduces the surface area of the pipe, because any material of plastic having pores, to reduce the surface area we provide coating. For counter those pores where current can leak or some damage in the coating, there is providing cathodic protection system to protect the pipeline from external corrosion. And installation, there is a many activities like trenching, string, welding, crossing, and health safety environment during construction. That is very much important for the pipeline. And finally, testing and commissioning. We will explain later on testing and commissioning of the pipelines. And finally, pipeline after installation, there is a markers, pipeline marker where pipeline is going on. And operation, that is intelligent pigging, leak detection system, SCADA, and disaster management system plan. Now, these are the activities, basically basic. First one is conceptualization. Conceptualization, then detailed feasibility report, basic engineering, and detailed engineering. In conceptualization, what we do? Basically, in conceptualization, we study various alternatives of the routes, pipeline, in which route pipeline is most techno-economically feasible, and what are the constraints in various routes, which route is less number of constraints. Accordingly, we select the option, this option must be select for the investment, and then prepare the detailed feasibility report. In detailed feasibility report, we define each and every route options, and we define each and every crossing, what type of methodology to be adopted for the installation of in that crossing. and hydraulic is the size of the basically pipe, and design requirements and requirements of basically MTO, material takeoff, how much quantity of pipes are required, how much material for station piping, what the land, how many parcels of lands are required, and total project cost is established, that is up to plus minus 10%. That is the detailed feasibility report. And then finally, environmental impact assessment as per the guidelines of Ministry of Environment and Forest 2006. Then we do basic engineering. In basic engineering, we define engineering design. What are the engineering requirement for the basically designing the pipeline system? And route surveys and investigation, basically topographical surveys, geotechnical surveys, hydrological surveys, soil resistivities. There are many types of surveys. And forming the basic design requirement like pipe material, grade, wall thickness, and many specs, construction requirements. And in detail engineering, then finally firm up the methodologies and engineering for procurement, job standard, wherever specification is not available, we prepare the job standard for the procurement and construction requirement. And if pumping station is there, then we have to carry out the stress analysis. Basically, if you see that this is the basically design formula for designing the pipeline. If you see, there are two formulas. One is based on ASME B31.8 for gas pipeline. Another is for ASME B31.4 for liquid pipeline. But if you see, there is a difference in these two formulas. One having the T, capital T, that is temperature derating. But in liquid pipeline, there is no temperature derating. Why it is so? Basically, gas is compressible and liquid is incompressible. Then if leakage in gas, that is a disaster. And gas operated at high pressure, when temperature goes high, then material strength getting reduced. That as per code, the gas pipeline up to 232 degrees centigrade can be designed. But in liquid pipeline, up to 120. 120, as per the code, there is no requirement of temperature derating. But beyond 120, there is a requirement of temperature derating. If you see, the temperature derating is for steel. Up to 121, there is no derating. But beyond that, there is a derating factor. Material strength is getting reduced. These are the basic reports which we prepare during design, basically wall thickness analysis. Normally, wall thickness is calculated based on the hoop stress. Some thickness may be coming, suppose 5 millimeter or 10 millimeter, whatever it may be. Then we analyze the pipeline is passing through beneath the railway, beneath the highway, river, roads. Then we analyze based on the API 1102. And according to that, which thickness comes to higher, we have to select that. Then again, we have to check if pipeline is passing through the seismic zone. Then we have to analyze seismic requirements. And if thickness have to be increased, then it has to be increased. And that much thickness to be selected, not based on the hoop stress. Which thickness comes higher, based on that thickness, we have to select that. And we have to compare that, whether this thickness is available in the market or not. According to that, we have to check out what thickness of plate or what thickness of pipe is available in the market. But if quantum is more, as per API 5, nowadays, any thickness can be manufactured. So if quantum is more, then we select based on that thickness. This can be, quantum is high, this can be manufactured. But if pipe quantity is less, then we have to go for the standard thickness. This is the basically line pipe selection criteria. This is the most important because it belongs to 35 to 40% of the project cost. The line pipe basically is selected based on the fluid characteristic, the type of fluid, whether gas, liquid, corrosive or non-corrosive, which type of fluid to be transported. And operating condition, what is the pressure and what is the temperature. Suppose it is permafrost region, then we have to select according to material to according to that. And mechanical properties, what is yield strength? Whether it is a grade B, grade 42, 46, 56, according to that we have to select that. And toughness, CHARP requirement. CHARP, basically what is the operating or temperature of the pipeline fluid. According to that we have to take CHARP requirement. And hardness of the material is very important for the line pipe. And various standards, normally in India we follow the API standard for procuring the line pipes, and environmental parameters like extreme temperature, geographic consideration, and external corrosion. Suppose soil resistivity is very high, then we have to take according to that material. And welding and fabrication. When we select the pipe, we have to see whether pipe formation will be easy or not. Suppose very tough material, then pipe formation will be very difficult. You can ask Mr. Bhavin Mapra, he is well spun and he can explain very well. And weldability of the pipe, because weldability have to ensure that, because suppose in manufacturing plant it can be manufactured, welded, but at site it is very much required to be weldable, and there should not be much defect in the girth weld. If defects are more, then pipe is not suitable for the pipeline. And cost consideration is very important for the pipeline in line pipe, because material cost and installation cost, maintenance cost, all three costs have to be seen during selection of the line pipe. Then pipeline route surveys, and these are the basically shortest route, obstruction, avoid obstruction and sensitive areas, installation limits. And suppose you are going by a hill, then you have to see whether this, what length of pipeline can be installed in this. Suppose 12-meter pipe you are not able to install, you cannot take that pipe up to that height, then you have to take 6-meter length of pipe or 4-meter length of pipe. According to that you have to select that. And crossings like river crossings, ponds, marshy lands, railways, highways, according to that as minimal as possible. Then that is topographical data, surveys, geotechnical, hydrological, PDI, basically population density index in case of gas pipeline. There is a gas pipeline, then there is a population density index, because there is a class 1, class 2, class 3, class 4. There are 4 classes. If population density is less than 10 dwellings, then it is location class 1. If it is 10 to 46, then it is location class 2. It is more than 46 dwelling, then it is a location class 3. If multi-storied building, suppose passing through city areas, then it is location class 4. Accordingly, design factor is getting changed, because I have shown in the earlier slides, previous slides. Then line pipe selection I have told you, and thickness and grade selections, handling and transportation of pipe, because D by T ratio is very important. Normally, what we select, the D by T ratio should be less than 100 for the pipe. According to we have select the, suppose thickness is coming by pressure, it is less, and D by T is getting more than 100, then we have to not select that. We have to select the based on pipe or D by T ratio. To control the D by T means thickness will be get increased. Type of line pipe, like SAWL pipe or SAWH pipe or HFW pipe or seamless pipe. What type of pipe is required to be selected? Because there is a manufacturing range. If you see seamless, up to 16-inch seamless can be manufactured. And high frequency welded pipe, basically we take normally 20-inch, but few of the manufacturers like Tata Steel manufacture up to 24-inch HFW pipe. And longitudinal welded pipe, 16-inch and above. And helical welded pipe, 18-inch and above. These basically coating selection criteria. As I told, coating is very important to reduction of the surface area of the pipe for cathodic protection. The coating selection criteria, if you see, the service conditions, performance of the coating, and anti-corrosion properties, electrical properties like dielectric strength of the basically coating material. Ease of application means application when coating is applied at the coating plant, then ease of the application. And after coating application, repair should be easy for that and cost effectiveness of that. And coating should be UV, basically UV protection. It should not be degraded when we keep the pipe on the open sun. Then there is a wall selection criteria. If you see wall is very important in pipeline, like sectionalizing wall. There are many types suitable for intended service and application. Suppose it is gas, crude oil, white product, and wall bore shall be API 6D, because wall is based on API 6D as per codes and standards. Easy operation and maintenance. Whoever is supplying that have a previous track record, means previously he has manufactured that type of wall and supplied to somebody and it is in operation. That is very much important, because if first time it is making, then it may not perform well and your basically investment get lost. Then lowest O&M cost, operation and maintenance cost should be lower. Sectionalizing wall should be full bore, because we have to pass the pick through the walls. And welded body design. Normally all sectionalizing walls are welded body design, because if it is flanged, then there is a prone to leakage. That's why all sectionalizing walls are welded, means it is buried and welded body design. And for operation, there is a stem extension. And most important is availability of vendors. That selection criteria define vendor must be available, because if vendor is not there, how are you going to purchase the walls? Then SV selection criteria. As I told you, SV selection is very important. As I told, in gas pipeline, there is a SV installation if belongs to class 1 location. Then there is a spacing requirement is 32 kilometers. If in class 2 location, then it is 24 kilometers. 3, then it is 16. It is in 4 means city area, then it is 8 kilometers. But you have to carry out the PDI, Population Density Index survey. Normally, what our surveyor does, survey agencies, they take 1.6, 1.6, 1.6, 1.6. But this is not 1.6 kilometer long and 400 meter wide. They take and accordingly they survey and put this much population, this much population, this much population. Basically, this is not the correct method to do the population density index survey. That is called end-to-end mile survey, but we do sliding scale survey. Basically, we have to select 1.6 kilometer, we have to check, then slide it, where density is going to change. According, slide, then you have to optimize how much is class location 1, how much is class location 2, how much is class location 3, how much is class location 4. That is the optimized way of the doing population density index. According to that, we have to put the walls. The space, basically locations should not have the power lines. Wherever you are selecting the location, there should not be over plot of the land. Must be connected to all-weather road. Wherever you are installing the SV, that should be connected to all-weather metalled road, means we can say. Because if it is kacha road, you cannot move all time. Suppose in rainy season, if you see the liquid hydrocarbon pipeline, in liquid hydrocarbon pipeline, that is maximum spacing requirement is 50 kilometers. And as per guidelines, codes, the upstream and downstream of the rivers, water bodies, there should be a wall. Previously, it was written as close as possible. So everybody was playing to that, ki as close as possible ye hoga. But now it is defined in OSD 141 latest, that is 6 kilometers from the bank of the river. So now you have to choose in that. So that is defined. Another consideration is access required, that I told you, all-weather accessible. SV should be free from existing structures, obstructions such as electric poles, pylons, etc. Location to be checked. When we select the SV location as a engineering consultant, we see the basically imagery, whatever available in public domain, and survey alignment, whatever survey data provided by the client and carried out by the survey agency. According to that, we see where is the all metal road, whether this location is any electric pylon or electrical line is there or not. According to that, we select the location with considering the code requirement, the 32, 24, 16, 8 or 50 or 6, whatever it may be. And area should be free from flooding, inundation, जो water logging नहीं होना चाहिए उसमें. Then major river crossing, perennial in nature, meandering tendency, and potentially erodible banks नहीं होनी चाहिए. Basically जब meandering, जब serpentine river होगी तो normally वो erode करती है. तो उसके लोकेशन को हमको स्टडी करना पड़ता है कि ऐसा ना हो कि एसवी लगा दें और उसके बाद वो इरोड होकर एसवी ही पानी में चला जाए. तो उसके लिए स्टडी करनी पड़ती है. एक जियो मॉर्फोलॉजी करके स्टडी होती है जो जियो टेक्निकल डिपार्टमेंट करता है और वो इस्टेब्लिश करता है कि इसके आगे ये नहीं जाएगी. देन चैलेंजेस ऑफ एसवी लोकेशन सिलेक्शन. बेसिकली हमने सेलेक्ट कर लिया बट देयर आर मेनी चैलेंजेस. बेसिकली सपोज हमने बताया कि यहाँ पे एसवी लगाना है बट हो सकता है वहाँ लैंड ही ना मिले या कॉस्ट बहुत हाई हो. तो कॉस्ट इंकर्ड फॉर द एसवी स्टेशन इज वेरी हाई. इट डिपेंड्स ऑन द लोकल cost of the land. It puts significant burden on the capital expenditure as well as expenditure on the owner. Basically, if location is, that's why we take margin somewhere कि अगर plus minus इतना होगा तो हो जाएगा. Issues pertaining to purchase of suitable land, availability of required. Suppose एक आदमी बोलता है नहीं हमको नहीं बेचना है, एक बोलता है हमको बेचना है, तो आपको उतने साइज का लैंड ही नहीं मिल रहा है, तो भी एक दिक्कत. तो नॉर्मली हम यही कोशिश करते हैं कि जिसमें कि वो एक साइड का लैंड मिल जाए उसका. अवॉइड आर्कियोलॉजिकल एंड डिफेंस एरियाज, फॉरेस्ट सेंचुरीज, हेरिटेज एरियाज, माउंटेन्स एंड हिली रीजन शुड बी अवॉइडेड. डेजर्ट एंड सैंड ड्यून्स शुड बी अवॉइडेड. कंसिडरिंग द अबव, नंबर ऑफ एसवी required must be optimized. So how optimization is done? If you see in this, based on the sliding PDI, as I told, number of SV station can be optimized considering the predominance of population location. If you see, and liquid hydrocarbon pipeline, considering the challenges of associated with SV station, locations instead providing the dedicated SV on either side of the river, each SV station have to be optimized. If you see the diagram, there are two SV with two rivers. If two rivers are close to each other, then we optimize and provide only two SV. Otherwise, as per code, 4 SVs are required. But in second one, if you see, two rivers are little bit away. Then we have, in between, we have put one SV. As per code, it is another SV is required because 4 SVs are required. So that much optimization we have to carry out based on engineering analysis. This is the SV land requirement. If you see the gas pipeline, we have given the overall plot requirement and what are the process area requirement. If you see the dimensions, process area requirement for each and every size of the pipeline, this is the typical one, and overall plot requirement is this. And for the liquid pipeline, this is process area requirement is this, and overall plot requirement this, that is indicated in this. These are the typical pipeline components, that is a scraper launcher, pick, insulating joints, and floaties. Now pipeline construction. There is many stages in pipeline construction. One is pre-construction survey, then installation, then crossings, testing, pre-commissioning, and commissioning. In pre-construction, route survey, ROU clearing and grading. These are the requirements before digging the trench. Then installation, welding. Welding is very important for any pipeline system. There are 4 types of welding procedures. One is WPS1 called main line welding. Another one is WPS2 called tie-in welding. And third one is repair welding procedure, and fourth one is also full repair welding procedure. And in pipeline, normally WPS1, that is totally downhill welding. And in WPS2, that is tie-in welding, because there is a cutting involved in the pipe. Pipe is not as smooth as manufactured in the pipe industry. That's why in that case, all passes are uphill. Then NDT. In pipeline, normally if you see the plant piping, there is a gamma ray carrying out the NDT. But in pipeline, X-ray is mandatory. All joints must be X-rayed. And in pipeline, normally as Tiwari told, pipeline is not going in a straight way, in different directions. That's why cold field welding is very much required. So up to pipe size greater than 18 inch, that is 40D radius of curvature is required, and less than 18 inch, that is 30 times diameter of this. And ovality should not be more than 2.5% of the pipe. Then pipeline crossings, that is open cut method, case crossing method, and HDD crossing method. I will explain the HDD crossing more, and microtunneling. This is the pipeline construction testing, hydro testing. If you see, hydro testing, one of the most important part of the pipeline after construction. That is strength test, you can say integrity test, whatever it you can say. Then first pipeline, you have to define the section, how much length you have to take in one section of hydro testing. As per EIL requirement, you can say, that is, I defined 50 kilometer. You can say 50 kilometer section for hydro testing. But you have to see the whether water is available in that location or not. So first you have to make the hydro test section planning. How you make the hydro test planning? Because based on the elevation of the area. We have to carry out P maximum, how much maximum pressure is there and how much minimum pressure is there. According to that, we have to calculate the height. How much height can be, where maximum pressure is there. According to P equal to HDG, you have to calculate the height and you have to select how much length can be taken. May not be 50, maybe 35 kilometer, because that height get increased in 50 kilometer. That's why we have to select the section length and water source. If water source is available, according to that, you have to make this section. Then you have to, first you have to carry out the air cleaning of the pipeline in that section. Then after air cleaning, you have to put the testing headers with 4 cup batching loaded picks. When you do hydro testing, previously you have to put 10% of the section of the volume of the water previous to that. And then 1.5 kilometer column between 2 picks. Because water filling is very important, very much important in the pipeline. Because it goes in different direction, different elevations. If you not careful, then air will entrap in the pipeline system and you cannot remove that. For that, there is a calculation in the hydro test specification. How much air is acceptable in that section? That is only 6%. So accordingly, you have to fill the section, then you have to thermally stabilize the pipeline. For that, you have to install the thermocouples. If you see the thermocouples, how you install, how much distance it has to be installed, and thermal, how you can say that pipeline is thermally stabilized? When the temperature of the average temperature of the soil and average temperature of the pipe difference is 1 degree. Then you can say pipeline is thermally stabilized. After thermal stabilization, you have to start with the hydro test pressure cycling. In pressure cycling, you have to check whether air, how much air is entrapped in this. Then we have to calculate theoretical volume by formula and practical volume by dropping the 0.5 bar pressure, and you collect the water. then collected water divided by the theoretical water calculated, that ratio ideally should be 1. If it is not 1, it should not be more than 1.06. If it is more than 1.06, you have to calculate, and you have again, if it is not coming within the range, then you have to refill the water. You have drained out and refill the water. And finally, the acceptance criteria of this: when water is filled and everything is okay, then initial pressure and final pressure after 24 hours, the difference should not be more than 0.3 bar. If it is more than that, then something is wrong. Or your calculation is wrong, or section length is wrong, something is wrong, or somewhere seepage is there. You have to extend more than for another 24 hours, that is 48 hours. If it is again there, then you have to again recheck the whole process you have to do. Pipeline, pipe book, pipe length, everything again check. If it is again is there, then you have to sectionalize and you check where is leakage is there. Now I am going to talk about long length HDD crossings. Basically, if you see, previous to 2000, in India there was SDD, nobody was listening कि SDD is there. Knows SDD is there in worldwide, but India में बहुत कम थी. Even India में 2004-5 में जब even 84-87 जब HBJ पड़ी, तो कोई जर्मनी से कंपनी आई थी जो SDD करने के लिए गंगा की. ये 2004-5 के बाद इंडिया में SDD, आज की डेट में nowadays SDD इस पाइपलाइन में almost 10 to 25% pipeline length is being installed by HDD method only. Every contractor is saying, where there is a pond, you do SDD. Where there is a small river, you do SDD. Basically, this is not good practice, but people are doing like that. So SDD technology has improved a lot. Basically, SDD is achieved by basically 3 parts of SDD. One is pilot drilling, another is reaming, means enlarging the hole, and third one is pull back the string. SDD basically depends upon the subsurface condition. Subsurface means suppose soil, then SDD is easy to carry out. Suppose it is rock, then it is good. Sand, then it is good. But if it is gravels, cobbles and pebbles, you cannot do SDD. If soil mixed with gravels, not more than 30%, then you can do SDD. But if it is more than 30%, you are next to impossible to carry out SDD. These are the SDD requirement, that is pipe diameter. Diameter is very much important in case of SDD. If it's very big, then length will get reduced. Material grade of line pipe, thickness of line pipe, cover requirement, length of crossings, entry and exit angle, radius of curvature, mud system. Basically in SDD there is a mud system. Normally we carry out SDD with drilling fluid. Drilling fluid is bentonite with water. 95% water and 5% is bentonite. And basically equipment is capacity of the drill rig, tracking system. As today now para-track system is there. Reamed hole size, how much hole diameter is required. Suppose you want to bundle pulling, then reamed hole size will be bigger. Why bundle pulling is required? Because you have to put the cable inside, OFC cable. And in SDD, drill pipe is very important. Nobody asks about how much quantity you have drill pipe. Suppose you want to carry out SDD of 1000 meter, then you require 2 kilometer of drill pipe, if you ideally carry out. Otherwise, you have to again and again, you have to transport the pipe here and there. Now the technical feasibility and pilot hole limitation. The technical feasibility of basically the SDD is depend upon the length of borehole, pipe diameter, and subsurface conditions. As I told, geotechnical data. Basically, it depends upon the hole. Hole is, it is fluidized or open. Fluidized means जो बेंटोनाइट आपने उसके अंदर डाली है वो बेंटोनाइट फ्लूइडाइज्ड कंडीशन में होनी चाहिए। जब फ्लूइडाइज्ड कंडीशन में होगी तो वो आपकी जो कटिंग्स होंगी ना अंदर उनको बाहर लेके आएगी। अगर फ्लूइडाइज्ड नहीं होगा मीन्स होल कहीं ना कहीं ब्लॉक हो रहा है। Then pilot hole limitation. Pilot hole limitation, basically it depends upon the three factors. Compressive, basically he take three loads you can say. Compressive, bending and torsional. Compressive means you have to thrust that. Bending, matlab when you thrust that then torsional load, and it become bend when you put the load more. When you put the load from one location, there is inside a bottom hole assembly where you can tilt the angle 1.5 degree, because when you go this way then straight it then up. So after certain length, certain distance, you cannot maneuver from that location. Means you can say difficult to control from that location. That's why up to 2,200 meters by one rig you can carry out the SDD easily. But if there is a longer length, we have carried out in Paradip Numaligarh pipeline Ganga at 4,000 meter SDD, Bhareli river 4,000 meter SDD, Subhansri 4,000 meter SDD, even Brahmaputra we are carrying out 4,000 meter SDD. For that we required intersect method. In intersect method what we do? We put two rigs, one rig from this side and another rig from other side. Carry out the hole from both sides, pilot hole. And there is a tracking system. Both machines are communicating with each other and track when we come to closure, come to the handshake of each other. At that time we stop one rig and we forward one rig. And after meeting, we backtrack this rig and this whole, because there is a path. Now you can easily go to that path and HU intersect. If you see in the figure, there is a two rigs intersecting with each other and there is a tracking system. By this way, if you say effectively you can double the length. Means what is 2,200, now you can go 4,000. Even in Hong Kong, 5,000 meter they have carried out SDD with intersect method in Hong Kong airport. Able to decrease the risk of hydrofracture, because if you put one side and put a pressure, then it will frack out. Hydrofracture is there because pressure is more inside the hole. Minimize the catastrophic failure of downhole. And intersect simplifies the conductor. Both sides you can put the conductor casing if soil is not supporting to that. And eliminating the hydrolock during pilot hole drilling. So by conclusion, I can say that pipeline integrity in design involves ensuring reliability, safety of pipelines throughout their life cycle, including material selection, SV selection, coating selection, best construction practices, corrosion prevention, erosion monitoring to prevent leaks and failures. Line pipe selection, as I told, wall selection, location are crucial for the pipeline system. With the advent of gas power plants, fertilizer plants, petrochemical plants, and CGD networks, pipeline have become the indispensable part of common man's life. Pipelines are the most environment friendly and safest means for oil and gas transportation. That's why pipelines have become integrated in the component of national energy security and become the backbone for the energy supply chain. That's why you can say that pipelines are underground energy highways. Thank you.